enterprises were not able to keep that data because of limitations. When it comes to limitations, that limitation was storage, like huge amount of storage, huge expense, and then again a read and write was not that optimized as per the need. So they thought that why to keep the data if we are not able to use it, if we are not able to make use of the data in order to extract important information. What is use of storing it? So they used to archive it, or they used to throw it away from their enterprise. Right. This was the fate some 3-4 years back. But when people started, when business scenarios changed, and when people started realizing that no, whatever is the age of data, at some or other point of time, the data can be useful. They started searching for some way of managing that particular data, right? So initiative was taken by a few companies, out of which Google was there, because Google's requirement was there. They have to store volume of data because they were searching. They used to use technologies like NUTS and all in order to store data and do analysis on data. But as time passed, they realized that this is not going to work out. We need to come up with a architecture where we are able to ensure that we are getting reliability in storage of the data, as well as we have a mechanism in place which is capable of analyzing the data or doing analytics on data for various useful information, right? So Google started working on it, and Google actually came up with some kind of a specification, some kind of product, and that product was basically named as GFS, that is Google File System. Now, this Google File System was actually a file system which was distributed in nature, which spanned more than one system, where data was not only stored on a single system, but it was stored on various devices or various hardwares, right, which was part of storage units in Google, right. So they found GFS pretty reliable because a basic objective of GFS was to ensure that data is never lost in case if one node is down. When I say node, it is machine. If in case if one machine is down, other machines must have a replica so that they can provide that particular data. So GFS was adopted by Google. Another paper which was released by Google was how to do analytics on this GFS, and as a result of which they wrote a mechanism, an algorithm, you say a framework. They wrote a framework, and that framework used to go and get data from various nodes which was scattered throughout their network, right. What they did here was they said that in case if I am starting one process to get the data, it is taking longer period of time. So why can't we do one thing? We can divide task of getting data into n number of parallel processes, and instead of invoking one process, why can't we invoke n number of parallel processes where each process will go and get data from a particular node, right? They realized it, and they found pretty better performance when it comes to GFS with combination of MapReduce, right? Google started working on this, and they found it very reliable, right? Yahoo was also there during that period of time. Yahoo was also working on the same concept, right? So they also came up with similar kind of architecture. Now Google thought that why can't we provide this particular technology to everyone so that everyone can use it. As a result of which, they released two papers. One paper was on file system, other paper was on framework, which was called as MapReduce, right. So if someone is asking you how actually Google and Yahoo and Facebook, these people are able to manage this volume of data, they are able to manage this volume of data because of very simple reason, because they adopted GFS and they adopted MapReduce, right. These two papers were used by some developers. I'll not name them as of now, right. Some developers, and they came up with a component, a product which was contributed to Apache. Name of that particular product was Hadoop, right. So Hadoop actually is a contribution, logical contribution from Google, and effort of few developers which gave this particular product to industry, where now big data is no more a challenge. Big data is an asset, and big data is being used by all companies which deals with huge volume of data, right? So first definition that we got here is Hadoop is combination of two important technology. One technology takes responsibility of storage, other technology takes responsibility of analysis of data which is stored and on this particular storage. In short, Hadoop is equal to HDFS plus MapReduce. Okay, yeah, Abhishek, I'll tell you. See, in case of normal programming, you have algorithms, right? For example, for searching you have algorithm, for merging you have algorithm, for sorting you have algorithm, right? Similarly, in order to do analysis of data in HDFS, which is file system of Hadoop, they gave a framework which was collection of n number of algorithms, keeping in mind how actually big data can be managed. And this set of algorithm or framework is what is called as MapReduce. Abhishek, is that clear? Okay, so we will work extensively with MapReduce. As of now, if what I said is clear to you that Hadoop is combination of two important technologies, one is HDFS, another is MapReduce, I'm fine, right? Because we'll be working out with this extensively, right? Now what we will do is we'll just go and start up with our presentation, which will first tell you why actually big data is important, and it will also talk about various steps you say in order to install, in order to configure and all, right? And how internally it works. First, let us take up some statistics. So when we talk about statistics here, if you see, big data was a challenge, right? Big data used to be a challenge. So big data used to be a challenge, but now if you see, this statistics will tell you that how actually big data is coming up and how actually big data is becoming a big opportunity in job market as well, right? So if you see, some of the statistics here tells you that big data is top business priority and drives opportunity for business improvement, right? Certain studies have also revealed that there will be, you say, investment or expense of $50 billion by 2017, right? IDC, which is one of the prominent market research company, has also forecasted that the big data market is expected to grow from $3.2 billion to $16.9 billion by 2015, right? If you see, number of people who are there as of now in big data is too less, and it is going to grow to a bigger number when it comes to availability of skill set who have capability of doing analytics on big data, right? And if you see, 14.9% of marketers polls in Crane B2B magazine are still wondering what is big data. That means big data is not still clear to most of the people. Why it is not clear to most of the people? Because they have not realized the, you say, capability of big data and how big data can be useful for their business. Okay, is that clear? Right. Now coming to another set of statistics, and this statistics tells you that how data is growing, how data explosion is happening in digital universe, right? So if you see today, 2.7 zettabyte of data exists in digital universe, right? And if you see Facebook, if you see LinkedIn, if you see Twitter, there is huge volume of data which is coming up in the system per hour, or you say even per minute, right? So in order to manage this huge volume of data which is coming up to these systems, right, they need to be ready to handle it, right? They need to have an architecture in place to handle it. Probably one of the solution is Hadoop for them, right? Is that clear? Okay. Now, why actually big data has been a problem and how actually you can target it? This is what we need to understand. Now, if you see, big data has been a problem because nature of data, which actually is handled by big data is diversified. In short, you have 3 V's which you have to concentrate on. First is variety of data. When I say variety of data, it means nature of data that gets pulled or that gets pushed in your system is diversified in nature. It's not only RDBMS, it's not only images, right? It is, you can say data can be structured data which comes in your system. Data can be unstructured data, right? Data can be huge volume of, you say ERP data which is being pulled in your system. Data can be also even user clicks which are being made on your website, which is really very huge in amount, right? So these are some of the important sources from where your system may like to pull data, but if you see here, data is of diversified type, right? If it is only RDBMS, it is easy for you to manage because you will be writing queries and all to manage data or to manipulate data. If it is unstructured data, file data, or data coming from various mainframes, again you have to adopt different technologies, different approach in order to manage that data, right? So we actually needed a common place where irrespective of whether data is structured or it is unstructured, we can provide a reliable mechanism for storage, right? This is what we call as variety of data, right? Fine. Second comes velocity of data, right? The way data is being projected to you, with what speed data is coming to you, right? What is the throughput of data? How actually users expect that data to be given back to them, right? So this actually is part of velocity, right? Third, very important, is volume of data, right? So if you see volume of data, you can see Facebook or you can see various applications, and when you do analysis of your application to decide that whether we also need to adopt big data solutions or not, you have to find out actually what is big data in your enterprise, right? Because volume will be different for different applications. So for me, big data can be of a different volume as compared to Facebook, right? It depends on what is my existing capability of handling volume and variety and velocity of data. If I find that I am going to be in problem after a considerable a period of time because volume, variety and velocity of data will be out of sync as per my architecture, it means that I have to go and make some architectural change there. And one of the architectural change is take up a big data solution and make that big data solution as part of your architecture. Hear me? Okay, so I was talking about big data, volume, velocity and variety. Did you got me there, or audio was not there during that period of time? Okay, fine. So I was talking about what big data is for our architecture, right? So see, volume is not fixed that if volume will be in terms of petabyte, then only I will consider to adopt big data solution, right? For each and every organization or for each and every enterprise, meaning of big data may be different, right? So what we need to do is we need to find out that what is current capacity of handling data of my system, right? And we need to have a roadmap that in case if volume, variety and velocity will increase, right, after 1 year or after 6 months or after 3 months, what I will be adopting, what I will be doing, right? So this vision needs to be there in market, and once this vision is there, as soon as your current architecture is not able to keep pace with the data, is not able to keep pace with the volume, you have to go and think of changing your architecture and adopting a big data solution, right? And one of the solutions can be Hadoop as well. Okay, is that clear? Fine. So if you see here, we have ERP, CRM, right? Then web, then big data coming from sensor devices, external data, business data feeds, video, audio, speech to text, right? SMS, MMS, all these are various sources which is creating a digital universe with huge amount of data, right? It means now data is present throughout the digital universe, right? And whichever enterprise is able to, yeah, I'll define it, Abhishek. Okay, whatever enterprise is able to do better analysis on larger volume of data, probably they will be more successful, right? Fine. So Abhishek asked a question that can we define big data precisely? Yes, we can. Big data is you say big data is a term which actually was evolved because of limitations of architectures to handle volume of data. Whenever there is increase in volume, variety and velocity of data which goes beyond capacity of an enterprise, that particular situation is what is called as big data, right? That particular problem is what is called as big data, right? It means now you have to do something because your data has grown up and now you need to make some architectural change in order to manage analysis, storage, right, of huge amount of data. Okay, you don't have any fixed unit that okay, if it will grow and go to petabyte, then only I will consider it as big data. Your enterprise may have different volume limitations, right? Is that clear? Good. Now we will see how actually your big data is managed, okay, by Hadoop, right? So as I already told you that Hadoop has a history where Google, Yahoo all contributed in order to come up with a solution which was contributed to or which was donated to Apache. Hadoop is nothing but it's a set of Java library, okay? So you can say Hadoop is a Java library which is a framework that helps you to manage big data, right? And how it helps you to manage big data? By adopting a very simple architecture, right? That architecture is, I will not ask you to go and buy sophisticated hardware. You have commodity hardware. You can use all those hardware in order to take advantage of Hadoop, right? It makes Hadoop cost effective. Your investment is in control. Why? Because you need not spend lots of money on sophisticated hardware and then softwares to manage those hardwares, right? So Hadoop was written as a library where it was divided into two parts. First part of library used to take responsibility of how actually data will be distributed across various commodity hardware, and this is what was called as a file system named as HDFS, that is Hadoop file system, right? Hadoop distributed file system. Why it is distributed file system? Because it is not present on a single system. That file system is present across multiple commodity hardwares. Okay, right? This is what was Hadoop. Now Hadoop is written in Java, right? Hadoop is written in Java, so you can use a very powerful mechanism called as MapReduce in order to write Java programs to communicate with HDFS. Okay. Now people from non-Java background, they also need not worry because this was on top of mind, that what if we have non-Java development and we want to use Hadoop, right? So you have various interfaces using which actually you can interact and do analytics with your HDFS. One of them is writing program in Java, Python, Ruby. Other is by using solutions, smarter solutions, which was contributed by Facebook and Yahoo, like Pig, Hive, right? You have various interfaces. So Hadoop is not only meant for Java developers actually, right? Even if you are from non-Java background, you can still contribute and you can do data analytics by using various interfaces provided or as part of Hadoop ecosystem. Okay, is that clear? So in short, what is Hadoop is clear, right? Manages big data by distributing big data across different commodity hardware and by providing a very smart analytic system in place called as MapReduce, which can be written in Java, Python, Ruby, .NET, as well as by using some smart interfaces in order to ensure that people from non-Java background, people from non-programming background are able to interact with Hadoop to do similar level of analytics, and those solutions were Hive and Pig. Okay, Kong, is that clear? Yes, we are going to talk about various ecosystem products, which include Hive, Pig, Scoop, Flume, Oozie, right? All these are part of that. So for workflow management, we are going to talk about Oozie, right? For data mining, we are going to talk about Mahout, right? So we are going to cover many, you say almost all important ecosystem products, right? We are not going to use any commercial product as of now. We will be working on core Hadoop so that you can understand how actually these commercial products are built, right? So at end of the training, you will be ready with your own commercial distribution of Hadoop actually. Okay. Okay. Now what is analytics? Very simple. If I have a database and if I ask you to find out, get me all employees who are from this department, this is analytics. Okay. So you have Hadoop which stores volume of data, and you have a need to go and get some information from existing data house. You will be writing a program, you will be writing a query, you will be using some interface to talk about that to the file system. That is what is called as analytics. Okay. Fine. Any questions, Kong? Jack, any questions? Okay. Fine. So if you see now, let's go and dive a bit in Hadoop, right? So what we will do in first session when we start. First session will be making your systems up with Hadoop, right? We will be passing on a document to you once you confirm. We'll be passing on one document to you where you will have all downloads that you have to do on your system, right? You have to prepare your system so that you can work with Hadoop, right? So we'll be passing out that document. After you have that document, you will do the required necessary downloads. Once downloads are there, I will do installation on my machine. You will do installation on your system. After Hadoop is installed, you will configure Hadoop, right? And then we will see what all different architectures are there of Hadoop. Like there are 3 different configurations that you can have of Hadoop. One is standalone. When I say standalone, I feel it is clear to you. Hadoop will be there on a single PC. I say pseudo distributed. It means I can have more than one process of Hadoop running on the same PC, providing you basic understanding of what Hadoop cluster is. Then we will go and talk about how to add an external commodity hardware to our Hadoop cluster, right? And then we will also talk how to decommission a node from an existing Hadoop cluster, right? So these are few things that we will be starting up in our first session. Okay, right? So I feel that what we will be doing in first session, that is clear to you. Now let's go and talk about how actually Hadoop works internally. Okay, all ready? Because this part is very important. This will actually help you to understand how Hadoop internally works in the system. Okay, right. So let's see. Hadoop is based on batch processing. This is what you have to keep in mind, right? Hadoop is not like traditional applications and hardware architectures, right? It means that it is not like existing application server or data server. It is a batch processing system. Just keep in mind, right? Hadoop takes a chunk of data that does from a particular commodity hardware, it will do something on it and then stick to somewhere else for another application to consume it, right? So meaning of this is your data is distributed on HDFS file system on various commodity hardware. Now when you want to do analytics, you will be invoking various parallel processes. Each process will go and get the data for you and it will create a collection of data, right? That collection of data you will use in order to do your analytics, right? And since n number of parallel processes are started, you will find throughput better as compared to traditional read and write operations. Okay, it's clear, Rakesh? Okay, fine. Now let's see what Hadoop is. Very simple. Hadoop is made up of two components. First component is HDFS, which stands for Hadoop Distributed File System, right? Now you see how it is different from traditional one. If you can see in the diagram, you have three different hardwares, right? And each hardware have, you say, n number of storage units, right? It can you also use RAID technology in order to have that storage in place, right? Hadoop file system will do what? Now assume that huge volume of data need to be handled, right? So what you will do? You will take that huge volume of data and you will put it on your HDFS. Okay. For example, I want data to be transferred from my local file system to HDFS. Okay. You will have command to do that, right? Like you have CP, right, for copying. Right. So what we are going to do? We are going to copy data from local file system to HDFS. Okay. When you do this, your HDFS does a task. What it does? It splits that data into n number of chunks or into n number of blocks, and it stores each block on a different storage unit. Okay. So assume that some 10 gig of data is coming. What it will do? It will divide that 10 gig of data into n number of equal manageable blocks and it will put it on the existing hardware. Okay. Ashwin, clear? Abhishek, clear? Okay, great. So now once it stores the data on various hardwares, read and write operation now will not happen in KBs, right? If you see, normal storage is in KBs. So when I do a read and write, it is in KBs, right? HDFS does what? It enables you to do read and write on a bigger chunk of data, which is of 64 MB, right? So it means that in one read operation, you will be able to read 64 MB of data instead of conventional 512 KB of data. So number of hits will reduce. Okay. Is that fine? Kong, is that fine? Okay, fine. Now, how actually Hadoop manages this HDFS? Very simple. See, HDFS is composed of two different type of nodes because HDFS actually works on principle of master-slave architecture, where one of the node will be node which takes responsibility of managing the entire data which is spread across all slaves, right? So in simple words, responsibility of master node is not to store data. Responsibility of master node is to keep metadata about data which is actually stored on slaves. Okay? It's clear? So what happens when you copy data from your local file system to HDFS? Step 1, it will break the data into n number of blocks. Step 2, it will request your master node where I should store the data. Step 3, master node tells client that you can store data on these nodes. Step 4, data goes and sits on those nodes which are delegated by the master node. Okay, master node contains what? Metadata, not data. Data is stored where? It is stored on slaves. Okay, Bala, thanks for joining. I feel that you got it right. Is that clear, Rakesh, what I said? Okay, fine. So now we have data spread across a number of nodes, right? And we are also aware that you have two different type of nodes. One is master node and others are slaves. Master node in Hadoop is what is called as name node, right? And name node keeps what? Name node keeps all metadata. Name node delegates all tasks or work to the slaves. Okay. Will there be risk? Yes, good question, Kong. Will there be a risk if one node fails during the process? Yes, single point of failure is your name node in this architecture. This is the reason why you have not one name node, but you can have more than one name node, right? In active, active or inactive passive configuration. So that in case if one name node is down, other name node takes over. Is that clear, Kong? Okay, fine. So I feel that we are at least clear with the basic of HDFS, what happens and what all are participants. You have two participants. One is name node, second is data nodes, right? Now we will see comprehensive how actually HDFS works internally, right? Now if you see, I am copying two files to my HDFS from various sources, right? It can be local system or it can be network system. Somehow I am going and making the data available or on HDFS. See immediately what it does. Your name node delegates that, see, you can store these three blocks of data1.txt and these two blocks of data2.txt on these nodes 1, 2, 3, 4, right? And also it maintains replica. If you see R equal to 3, R equal to 3 means for each block you have to replicate it into 3 copies, okay? And those copies will be spread across different slaves like backups, right? Absolutely right, okay? So if you see 1, 2, 3, they are present on various 1, 1, 1, 3 copies because R is equal to 3. And as an administrator, you can manage or you can maintain how many copies you want, how many replicas you want, okay? Is that fine? Okay, good. So what happens if one node is down? So if you see this node is down, right? If this node is down, your name node comes to know after few seconds because there will be heartbeat exchange between name node and slave node. In other words, your slave node will keep on propagating their heartbeat count to name node. In case if one node heartbeat is not heard by name node, it will consider it to be down. And once that node is down, name node will start doing housekeeping tasks. And that housekeeping task includes what? Your name node will always try to maintain replica as 3 because R is equal to 3. So in case if one node is down, yeah, I'll tell you. In case if one node is down, immediately your name node will create replicas and it will put it on other existing slaves. Okay. Now Kong is asking what happens if master node is down. Now in case if master node is down, everything will be lost, Kong, right? This is the reason why we have to ensure that we have architecture where we have two name nodes, right? One will be active. As soon as one name node goes down, other name node takes over, right? So failover can be configured. Earlier in previous versions, failover was not there, right? But in new versions of Hadoop, failover comes with core Hadoop as well. Okay, is that clear? Fine. So this is what and how actually HDFS takes care of the things, right? Now let's take a comprehensive example of Yahoo, and here you will come to know other units of Hadoop. See, you have racks, right? So first unit is rack. One rack contains multiple nodes, right? If you see, multiple nodes are there in this rack. Okay. Each rack communicate with each other through switches. Okay. So if you see here, you have n number of switches, right? Now if you see, your architecture is something similar to this. You have n number of racks where each rack has n number of commodity hardware, right? Those hardwares are nodes. Fine. Now we say that Hadoop has intelligence of rack awareness. It means Hadoop is aware about rack, right? See what happens. Why actually rack is important. We already know that whenever you push data to HDFS, it is going to create replicas of it. Okay. Now if you see, what if replicas are created in the same rack on the machines or nodes which are there in same rack, and if that rack is down, problem, right? All replicas will be lost. Okay. So as an administrator, actually you need not do anything. Why? Because your name node is aware about rack. So what it does, when it creates replicas and when it stores replicas, it ensures that it is distributed across different nodes which are present on different racks. Okay. You got it? Abhishek, you got what I said? So it will ensure that your data is distributed in such a way that failure can be managed. So your Hadoop will ensure that it is not putting all replicas on nodes which are there on the same rack, right? It is distributing that replica across different nodes present in different racks. Okay, fine. So this is what is one thing. Now if you see, preparing for writes, I already told you, but again I'll tell you what actually is meaning of this. See, you are client. Client is saying, I want to store data. It talks to name node. Name node does not have its own capability of storing the data. It will say what? Okay, go and write it on these nodes. Okay, then client will go and put data on that node, right? So you can see here one thing very clearly. It's not name node who will write data. It is client who will write data. But client will write data after doing negotiation with name node, getting address that where actually data can be stored, on what nodes data can be stored. Okay, is that fine? Fine, right? Okay, great. Now we'll go to you say some other part. This is what we will be doing in sessions and all, right? Here you have pipeline write, right? Meaning of pipeline is very simple. I told you name node is rack aware. So what it will do, when client writes a file which is distributed into 3 blocks, which has been split into 3 blocks A, B, C, it will ensure that it is writing replicas on nodes present on different racks. Okay. So you see, name node is rack aware. So it will put the data on data node 1 and data node 7, 9, and if you see here, these data nodes are placed in different racks. Okay. So this is how actually your HDFS works, right? Fine. Same is the case with read. Client will ask name node, get me the file. Name node contains metadata, that which file was broken down into what blocks and what are their physical addresses as of now on data node. Yeah, Kong, when we set up our network, right, in our network we have a unit called as rack. Okay, now that unit will be unit for n number of nodes. Okay, so when you do configure, you will assign rack number 1, node A, B, C, D, E. Yeah, it's like cluster. Okay, right. So we'll be touching upon it once we move forward. Is that clear? So as I told you, read also is something similar. Client will not directly go and pick up data from data nodes. It will first ask name node. Okay, and if you see, name node does what? It has replicas, right? So name node will go and get the blocks from the nearest nodes. okay, from the best possible nodes, right, which is nearest. Until and unless one node is not down, it will not look for other combinations. Okay, so name node contains algorithm to find out all blocks, right, which are nearest and fastest to be accessed by client. Is that clear? So all these are part of your name node feature. Is that clear? So I feel that you got an idea about HDFS. Let me again repeat it for you. You are putting some file on HDFS. HDFS breaks down it into n number of blocks. Each block is replicated and replicas are stored across different data nodes, probably present across different racks, in order to ensure that in case if one rack is down, replica is still available on other racks. Kong added a problem saying that what if name node is down? Solution to that is keep two name nodes, right, where two name nodes are fully connected to each other, sharing metadata, right, replicating metadata, so that in case if one name node is down, other name node takes over it. Okay, right? Fine. Now let's talk in brief about our second component as well, and the second component is MapReduce. You have stored your data. Now you have to do analytics on data. In order to do analytics on data, you have to use MapReduce. Now MapReduce algorithm does what? Whenever request is made to execute some piece of code on data, right, your name node goes and gets the data from your HDFS file system, right. Before it gets from a HDFS file system, on each node it does some analytics depending on your need. For example, you want to count how many words are present in a particular file, right, and that file was broken down into n number of pieces, right. So when you will do analytics, you hello, am I clear? Okay, I feel that everyone is able to hear. Yeah. Okay, Rakesh, you have to check your audio, right? So I was talking about a simple problem. That simple problem, which is a conventional problem like hello world program in any language. Here you have word count program in Hadoop, right? So you can say word count program in Hadoop is actually hello world program, right? So problem here is I have stored data on my HDFS. Now I want to count how many words have occurred how many times in a particular file, right? So what happens? You will write a MapReduce program. That MapReduce program will be submitted to name node. Name node will assign job to n number of data nodes, where each data node will find out how many occurrences of what words are there in the block which is stored on that particular data node. Okay, right? Is it clear? So now if you see, when you submit an analytics, we have concept of job, right? So each task that you want your your Hadoop to do is termed as a job, right? Now that job is broken down into n number of tasks, where each task is delegated to one of the data nodes to complete it, okay, on the data which it handles or which it holds. Okay, is that clear? Kong, is that clear? So if I ask you, MapReduce works on what principle? Very simple. Job divided into n number of tasks, each task delegated to your data node which handles the you say algorithm on that particular data. Okay. After all data nodes have executed specific steps in order to count number of words which are there in those blocks, you will have another phase, and that phase is what is called as reduce phase, where now it will create a collective report that okay, from data node 1 Hadoop a word was repeated 10 times, data node 2 20 times, data node 3 30 times. It will sum it up and it will give you the final result. Kong, is that clear? You don't worry about writing and all. I will make you write all these programs as well. Okay, fine. So it means that your map reduce is divided into two phases. First phase is map, where actually job is divided into n number of tasks and they are submitted to task trackers. Right now I am using a term called as task tracker. Those task trackers are present on data nodes. They take responsibility of executing the job. After job is executed on each data node, you have another phase called as reduce, where data is collected from all data nodes, output is collected from all data nodes, and summary is created. Here in case of word count, summary is adding up all the occurrences of words which occurred in different blocks stored in different data nodes. Okay, right? So sum it up, map reduce is equal to map plus reduce phase. Okay, where map phase is distributed across different nodes and they execute on their local data set. Okay, and after what where reduce result is collected. Okay, see result is again reduce phase when it is executed, right? The reduce phase data is made available for access to client through name node. Okay, it will be there in the cache. Okay, from cache it will be made available, right? Just we can see a small example. See big data.txt 1, 2, 3, and if you see big data occurrence 7, and this is what is map phase. Your task tracker executed on this particular machine, or you say this particular node, and it found these many occurrences. Here these many occurrences. Here these many occurrences. Right. The job is created. It is distributed to task trackers which are there on data nodes. Data nodes will go and complete the mapping part, giving you the result in form of collections, and then in reduce phase you will have the final result, right? If you see, this is what is reduce phase, where you get final result. Okay, is that clear? If you see now total occurrence, this is what happens in reduce phase. Okay, is that clear? Ashwin, it is clear, right? Oh, good, fine. So if you see now, these two are the components of Hadoop, and these two components are core component of Hadoop. So as a what role actually I will be playing? We can play two different roles. One is administrator, second is developer, right? Developer's responsibility is to write map reduce programs in order to do analytics, and administrator's responsibility is to ensure that sufficient data nodes are there. You have to commission one extra node, you have to decommission node, right? You have to take care of failover, right? You have to ensure that your Hadoop is present on right operating system. Communication or heartbeat count is being exchanged between your name node and data node. In case if one data node is down, you have to start up with the maintenance process, okay, to bring that node back in work. So this is how you will be acting as an administrator, right? There are various terminologies like data scientist and all also. The role of data scientist is to more work on development part, right? And this is what is the overall architecture of Hadoop. You see, client submits job tracker submits job to task trackers, okay, right? And these task tracker can interact with ERPs and various other softwares as well. But as of now, you assume that these task trackers are present on data nodes. Is that clear? Fine. Now, if this is clear, we will talk about in what flavors actually Hadoop is distributed. How long a job normally takes place. Okay, good question. Now, it depends on the bandwidth also, right? You will be testing your system, putting various bandwidth, taking up n number of data nodes, right? So whenever you build a system, you will have a predefined expectation of throughput. Okay, so you will configure your system. You will keep that many number of data nodes on a particular bandwidth with a particular network, right, which gives you the optimum expected throughput. Okay, if you see various tests has been done by Google, Yahoo and all, right? in order to prove that okay, if I am going to access a 10 TB of data, terabyte of data, how long it takes, right? So there is fight which is going on, but yes, we need to adopt a mechanism where we have identified appropriate bandwidth and appropriate number of data nodes in order to meet our requirement of analytics. Okay, you don't have any fixed formula. It depends on volume of data and all, right? So you have to do testing, and you have to keep on improvising or improving the resource architecture until and unless you are not getting the desired throughput. Kong, is that clear? Okay. Now Kong is asking a question: how does cloud computing apart from or different from Hadoop? Kong cloud is entirely different as compared to big data solutions. Okay, cloud basically talks about sharing of resources, sharing of hardware resources, sharing of platform, right? Hadoop's objective is entirely different. Yes, what you can do is you can have Hadoop installed on cloud, okay, where you are taking up hardware on the cloud, right? So you cannot actually compare. You can have Hadoop in local architecture as well as if you prefer going with cloud resources, you can go and create data nodes and all on cloud. Okay, like Amazon and all has provided you direct support to Hadoop, right? You can go and create Hadoop data nodes. Yes, Abhishek, true. Okay, it's part of data science. Okay, great. Now what we will do is I'll just show you flavors of Hadoop, right? See, Hadoop is open source, right? Almost all big companies have come up with their own flavor of Hadoop, right? Leading one is Cloudera because Cloudera is adopted by most of them. If you see, these are various flavors. You have MapR, Hortonworks, EMC Square has its own Hadoop, DataStax, Cloudera, Amazon, VMware, SAP, right? IBM, Netezza, Oracle, they all have their own flavor of Hadoop. Okay. Why we should go for commercial? It's a big debate actually. When you go for commercial, cost is involved, but yes, they provide you a very decent dashboard in order to minimize your configuration task. Okay, right? If we go and set up our own Hadoop, we will find okay, this high version is not working with this Hadoop, right? So we have to go and resolve those issues. If you go with commercial product, all those issues are already resolved. You get a ready to use Hadoop, okay, configured Hadoop, and you get a dashboard in order to go and manage your Hadoop administration. Okay, so task is simple if you go with commercial products, right? But for learning perspective, it is always good to go with core Hadoop. If you are good in core Hadoop, you will understand all commercial products. You have to just go and look at their interface and work. Okay, right? This is the reason why we have started up with which product have you used among them. Okay, fine. It depends. I have worked on various projects. Like if you see IBM, I have worked for IBM products where we have worked on ETL tools and all like data stage and all, right? So in that scenario, we have used Big Insight. Now Big Insight is nothing but Hadoop from IBM. Yes, what they do, they provide interfaces which can directly interact with IBM products. I have used Cloudera, Hortonworks also we have used, right? And then VMware Hadoop also we have used, where they have used Hadoop for keeping their virtualization data and all. Okay, so it depends on project. Project to project, we have to go and use different flavor of Hadoop. But believe me, once you are aware about core Hadoop, things are going to be simple for you. Okay, fine. So this is what is Hadoop ecosystem. There are various case studies which we will be taking up, right? And if you see here, after this, you say we will have again a session which will take you more inside Hadoop, right? But I'll just like to tell you that what actually we will, where actually is our starting point. Our starting point is from installation of Hadoop. Okay, installation of Hadoop is very simple. You need to download the binary of Hadoop, which will be a zip file. You have to extract it, right? Now you should ask me what is the minimum requirement of Hadoop. Okay, it depends on volume actually which you are going to handle. You can install Hadoop on any operating system, right? Preferred one is Linux, because whatever production Hadoops are there, they are sitting on top of Linux, right? Microsoft operating systems basically are used as you say testing environment, right, or a client, Hadoop client, right? They are not the right place where actually you have to go and install Hadoop. Okay, you can install Hadoop on Mac as well, right? But best installation or you say production environment is your Linux or any flavor of Linux. Okay, we will also be using Linux, right? Is that clear? Kong, is that clear? Abhishek, is that clear? Right. So it takes, how about network? See, Hadoop sits on top of HDFS actually sits on top of your local operating system, right? So if two systems can be connected to each other using whatever protocol, whether it's TCP or whatever, irrespective of protocol, that particular node can be federated in your Hadoop cluster. Okay, so network is also not an issue, right? Yeah, it supports Kong. Okay, right. So what we will do is we will be installing Hadoop, we'll be configuring Hadoop. For that you need to have VMware, so you can go and have VMware. I will give you step-by-step guideline how to install Hadoop and all. That is what we will be doing in our first session, right? So assume that I'm just starting here my VMware, right? You will get a list of all software along with installation steps, right? So before you will be having those downloads. You'll be having those downloads, right? And once you have those downloads, we'll be able to work, right? So if you see here, I have Red Hat, I have Hadoop appliance, and I have Ubuntu. So let me go with Ubuntu first. Take some time. Take some time to start up. Okay. Minimum requirement when it comes to RAM is at least 4 GB of RAM for core Hadoop, and if you want to go with Big Insight and all, your memory requirement will increase. Like Big Insight works on 16 GB minimum, right? Better is if you have 8 GB, because we'll be working on VM, that is virtual machine, to ensure that we have separate installation unit for Hadoop itself. Let it start, takes 1-2 minutes. Okay. Meanwhile, I'll just show you what all we'll be covering. Whatever is there, we'll be covering everything almost, because it's not big you say deal to work with them, but yes, we need to go and see this ecosystem, right? This is what will be our coverage. Okay, you will be setting up your Hadoop with all these components, right? You can, it can be on any PC, operating system will be Linux, then Hadoop runs in JVM because it is built in Java, so JVM will be there. So one of the requirement is you need to have Java installed. Then we will configure HDFS, we will configure MapReduce, right? And then we'll be using Pig, Hive, Scoop, Evro, right? Evro is for serialization, Scoop is for helping you to bring data on your HDFS from database, so you can do import and export from databases using Scoop. Then you have EGW, like these are various connectors. For example, you want to connect to SAP and all. Yes, all of them will be covering. HBase, Chukwa, Flume, Zookeeper, right? All of them will be covering as part of this training, right? So this actually reflects you the training agenda. Yeah, Abhishek. Now Abhishek is asking a question: what serialization is? Abhishek, see, whenever you want to put some data, right, in an external context, for example, to a file or on another system, right, what you have to do is you have to make that object serializable. If that object is not serializable, you cannot go and write it on a file or to a system, right? So for objects to be written or read from external context in your program, you need to ensure that it is serializable, right? Java comes with its own serialization, but Hadoop says that I'm not satisfied with Java serialization. It has lots of it's heavy, right? So they provided a simple and better serialization product called as Evero. Okay, is that clear? Right. So we have here now our virtual machine is started. If you see, I'll go to my terminal, right? And as I told you, like steps will be pretty simple. What you need to do, you need to download Hadoop. If you see here, we have downloaded Hadoop. I am talking about installation, configuration in other, and I have extracted it here in form of Hadoop 1.2.1, right? You have to ensure that these files are there. If you see bin, which contains all the utilities to start Hadoop and all. If you see, you have start, EFS, start all, start balancer, stop balancer. All these are utilities that help you to bring your Hadoop cluster up and down. Okay, it's clear. Then you have some configuration files also in this, like you have Hadoop env.sh, which will be present in conf. I'll go to conf. This is most important one. Okay, conf we will be using the latest version. Okay, this is a stable one, but we will be working on recent versions also. Okay, latest stable. Okay. Now if you see, these are configuration files. For example, Hadoop env, I'll be telling you what configuration you have to make in this, right? For example, if you see, one of the entries here is export Java home, which is pointing to my Java home, right? I'll tell you step by step. This is what is the first step. Tell your Hadoop which Java he has to use. Okay, Java 6 or 7 will also do. Okay, any version above 6 or above. Okay, so this is what is one step. Then you will go and configure your name node. For example, your name node should run at what IP and all, right? All that you will be configuring. See, here we have said that our name node works on what port, what node and all, right? As of now, it is local. This is what where you will say. For example, your name node is at a particular IP. You say 192.0.1.152, right? So for that, what you have to do? You have to specify that IP, right? So I'll be telling you all this in detail, right? And then you have HDFS types, right? Where you will configure how many replicas need to be created. If you see, we have here replications. As of now, one, because we have only one node, right? If you have more nodes, you can go and specify more, right? When you transfer your data from any file system to your HDFS, where that data should be stored, you are specifying the address. That data should be stored here. Okay. Okay. So we will be going through all these steps along with you, ensuring that configuration is done. Right. Now I told you that Hadoop works on master and slave. So here this file actually contains your master. You see, localhost is the master, and then this file will contain all slaves, IP addresses of all slaves. Right. As of now, we are on same machine, so it is one. If assume that you have 4 slaves, so you will write IP addresses of all those 4. Right. It's clear. Then comes map reduce, where you will control how many parallel processes can be started and all. Right. If you see the job tracker. Right. So we will talk about different configurations which are possible in these files. Okay. So steps are simple, right? Download Hadoop stable version. Extract it, configure using your configuration files, and then you can go and test whether your Hadoop is installed properly or not. Okay. For that, if you see, I'll just go to my Hadoop folder. I'll go to bin and I will write here Hadoop version. The minute I write, it will tell me if it is installed properly. It will tell me what is the version. If you see here, it tells you Hadoop 1.2.1. Okay. We are using here as of now local. Okay. But I'll tell you how to use it in distributed environment also. Okay. As I told you that when we will talk about configuring Hadoop, we have three. One is local, standalone. Second one is pseudo distributed. Third one is fully clustered. Right. So we will be talking about all three configurations. Right. Now you have checked the version. Rest is now you have to go and start the process. I'll write here start all .sh. Now you see what all it starts. First attempt is it is waiting to start name node. After name node is started, it will try to start job tracker, task tracker, right? Now you see it started data node. It is starting data node. So first name node, then data node, then task tracker, job tracker, secondary name node, right? All this will be started. See, secondary name node is started. Now please understand the secondary name node is just a backup. It is not going to get promoted to name node. Okay. I see task tracker also started, right? And job tracker also started, right? In order to confirm, you can just go and do JPS, which will tell you what all processes are started. These are the process ID and these are the processes which are started. Okay. I have not taken up configuration and installation as part of this because it takes another 1.5 hours to complete it. Okay. So that we will do in upcoming sessions. Abhishek, is that clear? Right. Fine. It's very. It's pretty simple. You'll not believe that Hadoop is how simple. Okay. Right. So this is how we will be working, and then we will work with various other components as well, like pig, hive, scoop, and all. Right. Which will give you clarity of how to work with Hadoop. Being Hadoop developer, good question. See, it depends on the complexity of the problem that you are handling, right? What is the case which you are handling? It depends on complexity of that. Okay, it's like the complexity is similar to complexity which you have faced in C program. Okay, so it will be like dependent on the solution for which you are writing your logic. Like in case of databases also, your complexity depends on what? Your complexity depends on the nature of data or which is being asked from you. It depends on complexity of the query, right? So here also it depends on that. Okay, but yes, you should be able to write efficient programs, MapReduce programs. Okay, where you have to take care of all best practices that you have to follow in order to write a program. Yes, logic definitely you have to build depending on the query. Is that clear? Kong, is that clear? Okay. What type of project you will be doing here? See, Abhishek, it depends on different companies in what way they are actually going to use Hadoop. Okay. Jack, it depends on what is your existing success. Okay. According to that, we need updates. But as usual, like you don't need any update. If you have Linux box, you can just go and install Java and you can get started up with Hadoop. That's all we will do in our first session when we start up with installation part. Okay. I will ensure that all updates, whatever are there, is there with you. Okay. Including path and location where you will get what download. No worries, Jack. We will install virtual box. Okay, we'll install VMware Player, and then I'll ask you to download a Linux image on that. Once you download a Linux image on that, you will go and you will be able to install Hadoop on it. Okay, is that clear? Yes, Abhishek, project is included in this. Okay, what project is included? You will have small different projects, right? I have made it very streamlined, right? For example, for pig and for hive, we'll have various for pig and hive will have different projects, right? It depends. Depending on the content, we will have small projects. Okay. Is there any other question that I have to take up? Okay. What is difference between failover and high availability? Good. See, when we talk about any clustered environment, it has two responsibilities. One is WLM, which stands for workload management. Okay, and second is failover and high availability. Right. When we talk about failover, it is just one of the concerns which makes your program, which makes your you say architecture be down. Right. High availability is something which is a comprehensive term. Right. Your system may not be available because it is too busy. It is not because of failover, because it is too busy, right? It may not be available for processing, right? So high availability is the objective that you get. Failover is the concern. Okay, it's clear that if one node is down, it means that your architecture has capacity of being highly available, but because one node is down, you are not able to get that expected result, right? So you need to ensure that your system never fails in order to ensure high availability to the customers. Okay, Bala, is that clear? Right. Any other questions? Okay. Yes, with this company we have started support for certification as well, right? What we do is when we take up the content now, with the content itself we focus on first level of certification. Okay. It's good. And when it comes to having certificate is always good, but nowadays you say scarcity is there in market for big data developers. So you may get job without even certification, but yes, certification is important. We will provide you all support from first session itself. Like what type of questions will come from HDFS, what type of questions will come from name node, what type of questions will come from data node, what type of questions will come from provisioning, what type of questions will come from commissioning and all that we will be covering. Okay. Now certification is important because you will be one of the persons who will be identified quickly, right? Getting interview call depends on screening of your profile. So in case if your profile specifies that you are certified, and in other profile if it specifies that I know Hadoop but I am not certified, obviously you will get a first chance for that particular position. Okay, Kong, is that clear? Yeah, BI is part of the picture, right? So we are not going to talk about BI products. We are going to talk about how actually Hadoop will interact with BI, how it will get data from BI. That is what is the part that we are touching upon. Okay, because when we go with BI again, it's a different area of study and we cannot complete it in 40 to 45 hours. Is that clear? Okay, so I feel that we all are set now. We are aware about what is Hadoop, what is big data, why Hadoop is needed, how Hadoop internally works, what is HDFS, what is MapReduce, and obviously what are different products in Hadoop ecosystem which we will be using. Right? Environment in which we will work with virtual machines, right? I will ensure all helps on your system, so to make sure that Hadoop runs on your system as it is running on my system. Okay.